Hello, good morning, everybody. Thank you for joining this webinar. The focus or topic of this webinar is NSX Data Center, the foundation for automation. Before I get started, I will just do a quick introduction. My name is Joshua Cooling. I'm a networking and security specialist systems engineer working at VMware, so I'm responsible for VMware's portfolio of networking and security technologies, of which NSX Data Center is one component of that portfolio. Before I dive into the detail this morning, I just want to spend a few minutes talking about where NSX Data Center fits within the broader VMware networking and security portfolio. And then we will also spend a little bit of time recapping the types of services that NSX provides and the use cases that NSX delivers against. So with that, you can see here the full VMware networking and security portfolio, at the core of which is NSX Data Center. So starting at the bottom left-hand corner of this slide, you can see NSX Data Center. This is the variant of NSX that, if you've heard of NSX in the past, you're probably already familiar with. This is the variant of NSX that you would deploy in the data center, where we take core networking and security services and we push those networking and security services into the hypervisor, and we distribute those networking and security services across the hypervisor fabric within the data center. More recently, VMware's been investing heavily in expanding the NSX portfolio from the data center into the native public cloud, and we achieve that using NSX Cloud. So we take all of the same principles that you may be familiar with as part of NSX Data Center, and we can take those principles of security, of automation, and distributed networking, and we can run those services within native public clouds. Today, VMware supports two native public cloud environments, that is Amazon Web Services and Microsoft Azure. Moving along horizontally, we can then see we have App Defense. App Defense is extending the least privileged security model that we're able to achieve with NSX at a network layer, and we can apply a least privileged security model to your applications themselves. In effect, what we do is protect a known good state or known good security posture of your applications. What we're then able to do is to highlight to security operations any deviations to that known good behavior. And not only can we notify to those deviations, but what we can also actually do is to prevent deviations from happening. Again, moving further across horizontally, we then have NSX SD-WAN by VeloCloud. This extends the NSX software-defined layer from the data center, from the native public cloud across the wide area network, giving us a software-defined WAN connectivity service. Last but not least, on the right-hand side, we then have NSX Hybrid Connect. NSX Hybrid Connect allows us to connect together disparate vSphere environments and allows us to migrate applications and workloads between those disparate vSphere environments. It handles any compatibility issues between those environments. So as an example, we could migrate an application from a legacy version of vSphere onto the latest version of vSphere whilst preserving that workload configuration or application configuration. So all of the technologies that I've just spoken about there are the networking and security virtualization technologies that underpin the VMware networking and security portfolio. Layered across the top of that, we then have management and automation tools that give us operational insights and, very relevant to the discussion today, automation of the components that I've just spoken about. So at a high level, these are all of the technologies that encompass the networking and security portfolio from VMware. Drilling into NSX Data Center specifically, I just want to spend a few minutes and talk about the types of capability that NSX Data Center provides before stepping into the automation use case specifically. So NSX Data Center, as I said, is the variant of NSX that you would deploy inside a data center. At the core of any data center remains physical infrastructure, and the requirement for that physical infrastructure doesn't go away. We are dependent upon those physical infrastructures to give us connectivity and to also provide us a platform within which to deploy NSX. So at the core of any data center is physical network equipment and physical compute, and that, as I said, doesn't go away when you deploy NSX. NSX has some dependencies on these physical infrastructures, so we require IP reachability within that physical network fabric, and we also require a slightly larger MTU. But with the exception of those two requirements, that physical network fabric could be a physical network fabric from any vendor deployed in any topology. What we then do with NSX is layer the NSX platform across that physical infrastructure, and in context of the hypervisor, what we're actually doing is deploying NSX into the hypervisor itself. What we're doing is we're taking core networking and security services, things such as switching, routing, firewall, load balancing, as well as several higher order services such as VPN, network address translation. We take those types of services and we're pushing those services into the hypervisor kernel. So we are able to run those types of services within the hypervisor itself. In effect, what we then have the ability to do is to connect our virtual machines, connect our containers to networks that are created within NSX. We're then also able to wrap security policy around those workloads themselves. So the security policy will follow the workload throughout its life cycle. So the point at which a workload is provisioned, it inherits a security policy. If the workload moves across the infrastructure as part of some resource management, the policy will follow that workload. So in effect, that's what we're achieving with NSX. Specifically, there are a number of services that are provided natively within NSX. So of course, we provide switching, we create an overlay, we can route between the switches that we create in NSX. We can also provide layer 4 through layer 7 load balancing. We provide connectivity to physical traditional networks. So we can provide end-to-end reachability between workloads in NSX and workloads outside of NSX. We have native layer 4 through layer 7 firewalling. We have VPN capability. We can then also augment the native security controls within NSX through our partner integrations. And then last but not least, on the right-hand side, we provide a huge depth of visibility that organizations can use to help monitor the NSX environment. On the left-hand side there, you can see that everything I've just spoken about is exposed through a user interface. So if I wanted to, I can come into the NSX user interface and configure everything I've just spoken about. But additionally, which is very relevant for automation, all of the services I've just described are also available to be consumed through an API. So everything can be programmed through the API in a fully automated manner. And everything within the platform that I've just discussed can be configured through policy, through groups, through tags. So everything can be programmatic in how it's configured. So that was a few minutes just to recap on NSX itself. Spoke a little bit about where NSX fits into the broader VMware networking and security portfolio. And now I want to step into the automation use case. And I think this quote from Network World really summarizes the fundamental value of network automation. And that is, network automation allows organizations to scale their business, but also it allows organizations to really drive cost optimizations, particularly when they are looking to scale their environment. So network automation is fundamental to achieving both of these things. And network automation is relevant to the business because the business requires to be competitive within competitive markets. Network automation allows the business to bring new applications to market faster. And ultimately, it allows organizations to be successful within those competitive markets. It allows organizations, the business, to respond to shifting customer demands. And from an IT perspective, automation is just as relevant as it allows them to support agile application development processes. It allows IT to drive better utilization of IT resources. And ultimately, it also enables IT to simplify and automate how they operate the network as well. So from a business perspective, we have a set of requirements that drive the need for automation, and automation in part then drives a series of IT optimizations as well. And what we're seeing over time is that the workload profile and the life cycle of workloads is changing as well. So historically, what we've seen is that there's been a lower number of application deployments, but over time, in today's environment, the rate at which we're deploying applications is increasing significantly. But also what we see is that the life cycle of the workloads that are being deployed is decreasing. So we're seeing far more transient workloads, but an increase also, therefore, in application deployments. So we're seeing an explosion in the number of applications that are being deployed. And clearly, to be able to meet these demands, we need to enable automation end-to-end within the enterprise. So typically, the reality of automation and network automation is in part of three. There's typically a set of manual processes that organizations need to follow when provisioning networks, when configuring security. What we also see is that connectivity between workloads and applications is inconsistent. The security posture can vary wildly across the environment depending upon where a workload is provisioned. Is it provisioned behind a firewall? Is it provisioned behind potentially a different firewall somewhere else in the data center? So what we see is inconsistencies from a network security perspective. And lastly, what we then see is management of applications is increasing as we see different types of infrastructures deployed, different security measures that organizations can use to secure those applications. So what we're seeing is an increase in complexity as well. So network virtualization is a foundational component to being able to automate a network and also to drive security for ultimately greater application agility. And this is relevant with NSX for it is traditional applications, i.e. monolithic applications, as it is for new application frameworks, more cloud-native application frameworks. So through network virtualization, we're able to achieve, largely speaking, three different types of use cases. The first is IT automation, which really focuses on automating the provision and automating the deployment of traditional applications. The second use case that we're able to enable from a network automation standpoint is cloud-native automation. So this is really about providing enterprise-grade networking and security for both containers and microservices. The third use case is around streamlining operations. So given that we're able to drive consistent networking, consistent security for different workload patterns, we're able to simplify operations. So we can automate the troubleshooting process, we can automate the security planning process, and we can automate the capacity planning process. So in simplistic terms, this is about automating the traditional work, this is about automating today's work, and then this is about automating everyday work. So what I'm going to do is I'm going to walk through each of these use cases in a little bit more detail, and I'm going to start with IT automation. So most simply, what this the challenge that organizations face with IT automation is that some of the infrastructure and service provisioning process is automated. So it's fairly straightforward for organizations to automate the deployment of a virtual machine. And organizations have seen huge benefits from this process. However, in this provisioning process, there are still manual configuration processes. And typically where we see those manual processes is within the networking and security domain, where we just haven't seen the same levels of automation that have been achieved with the compute provisioning process. Networking and security can typically add days or even weeks to the provisioning process. And if changes need to be made early on in that provisioning process, then this whole deployment lifecycle needs to be restarted, which adds further delay to the process. So what we're able to do with network virtualization, and specifically plugging in automation technologies to network virtualization, is to provide networking and security services within NSX, use a cloud management platform such as vRealize Automation, or really it could be any form of cloud management platform, providing it can consume a RESTful API. We're able to blueprint the entire application, an entire multi-tiered application, including all of the networking and security requirements. What that means is that these services can be deployed faster, can be consumed in a variety of ways, whether that's through a self-service portal, or maybe if you want to drive more of an infrastructure as code consumption methodology, you could consume the NSX API directly. So whilst we have our own automation tools at VMware, so vRealize Automation would be our solution, we can, as I said, really connect any form of cloud management platform to NSX, whether that be something like Terraform, whether it's something like Ansible, or maybe integrating your own tools such as Puppet or Chef, using the NSX SDK. So ultimately, we're able to streamline this provisioning process, including all of the networking and security components of an application, to reduce that deployment time to minutes. And we can publish those multi-tiered applications in the form of a blueprint. So that was IT automation. What I want to do now is spend a few minutes talking about cloud-native automation. So this is taking the enterprise-grade networking and security technologies from NSX and applying these to a more cloud-native application architecture. So the reality is, for cloud-native application architectures, is networking and security for these types of technologies does exist. But what we see is that these technologies typically only provide a specific feature or function required for that application. So if we take the examples of some of the open source networking technologies, they'll provide you a very specific capability, but they don't provide you a full set of networking and security capabilities, from switching through routing, through load balancing, through network security, network firewalling. They'll only provide you a subset of that capability. What organizations then need to do is to bolt together multiple technologies to achieve a similar outcome to what we're able to achieve with NSX. So those open source technologies are often incomplete from a networking and a security perspective. And given that they're incomplete and we're stitching together multiple technologies, this approach is very resource intensive for enterprise IT. Typically, there's a set of manual tasks that need to be done to enable these technologies and integrate them together. So from a networking and security perspective, there's a lot of effort that needs to go into deploying those applications within these cloud-native application frameworks. And ultimately what this does is it puts an additional burden on IT teams. IT no longer need to accommodate the traditional applications and the technologies that go with those traditional applications, but they need to support these new emerging application architectures as well. And ultimately, at the end of the day, cloud-native application architecture is about being agile, about achieving high levels of agility and automation, particularly including automation of networking and security as well. So if we look at what we're able to provide with NSX, we're able to provide an end-to-end set of networking and security services that are enterprise grade for a containerized application. We're in effect able to treat containers as first-class citizens when it comes to networking and security. The automation and the way in which we've integrated NSX with these application architectures is in an agile way. We're able to fully automate the provisioning of networking and security services for containers such that we don't inhibit the developer. So the developer experience ultimately shouldn't change. And we can drive automation in a number of different ways with NSX for a cloud-native architecture. We can enable an infrastructure as code methodology. We can drive through an API. And as I said, really, the networking and security services that we provide as part of NSX are really architected to be part of that developer workflow. We don't want to inhibit the developer's ability to do their jobs. Now, one of the unique differentiators of applying NSX to cloud-native architectures, such as architectures based on Kubernetes or OpenShift or the Pivotal Container Service, is that we're able to provide consistency. We're able to give enterprises a consistent approach to building networks for virtual machines, for bare metal workloads, and for containers. We're able to give enterprises a consistent approach to securing those workloads, whether it's a bare metal, a virtual machine, or a container. So we're able to drive consistency for the enterprise. And for IT, this means that they can adopt these new emerging technologies without increasing the burden on IT teams. Okay, so that was cloud-native automation. And finally, what I'd like to do now is spend a few minutes talking about streamlined operations. So how can we automate and accelerate IT operations using NSX? So the typical challenges from a network operations perspective is that doing functions such as capacity planning, security planning can be very difficult. It's very difficult to gain end-to-end visibility across the entire physical network. There's often challenges in getting visibility into where or how workloads are communicating. How does traffic traverse across the entire network? What this means is that as we have gaps in this end-to-end visibility, is that capacity planning is very difficult to do. It's very hard to understand how best to utilize these physical infrastructures, and in turn how to drive greater consolidation of the resources that you may have within the data center. Additionally, organizations want to strive or move towards a model of zero trust or least privilege within the network, but not having this end-to-end visibility also makes that very difficult because we don't know how things are communicating end-to-end. What this also means from a troubleshooting perspective is that troubleshooting is typically manual. We need to log on to the disparate network devices, connect to those, run our troubleshooting triage commands, gather the outputs, and do this for any physical network device within the data path, and really stitch together what data we do pull from these physical infrastructures, and use that visibility that we gather over time to troubleshoot any issues. But clearly, this is intensive, very labor intensive. This is a set of manual processes that you need to go through. So one of the core tenets of NSX Data Center is the fact that it provides this end-to-end visibility across all of the components within the NSX architecture. We have centralized control, centralized management, centralized visibility. Visibility can be provided using either the native monitoring management protocols that are provided within NSX. So we have an API, we can export syslog data, we can export SNMP information, or we can connect tools such as vRealize Network Insights, which can be delivered on-premise, or we can also deliver it as a SaaS-based service to give us complete visibility across the NSX domain. We can have full visibility into how things are communicating, what traffic flows look like. We have the ability to support both the traditional monolithic application as well as the cloud-native application. We can also connect tools like Network Insight into the cloud environment. So as we look to drive consistencies using NSX Data Center and NSX Cloud, we can also provide you consistent visibility using Network Insight across data center and cloud locations. This also becomes important as it allows us to automate and pinpoint any issues within the network that requires remediation. So in terms of troubleshooting the amount of time it takes to troubleshoot issues, we can radically reduce the amount of time it takes to troubleshoot those issues. Additionally, this end-to-end visibility allows network operators and infrastructure operators the ability to think about proactively monitoring the environment. So proactively doing capacity planning, proactively think about microsegmentation across the entire environment. So in summary, from an automation perspective, network automation is enabled by NSX Data Center and then plugging in cloud management platforms into NSX Data Center. Cloud management platforms could be things like vRealize automation that allows us to publish multi-tier applications, including all of the networking security services those applications need, and publish those applications into a service catalog and consume through a service catalog. But as I said, we then have the ability to also connect effectively any cloud management platform to NSX Data Center that supports a RESTful API. And we have additional out-of-the-box integrations with things such as OpenStack, with Terraform, with Ansible, but additionally there's an SDK. So if you want to develop an integration with any other cloud management platform, you have the ability to do that. And also with network automation, you need to think about automating the day to operationalization or day to operational visibility of network operations teams, and that's enabled using Network Insights. So we can automate what we traditionally needed to automate from an IT automation perspective. We can automate the networking security services for cloud native workloads. And then, as I mentioned, we can then automate everyday network operational tasks using technologies like Network Insights. So if this has been interesting, there's a number of useful sources of information to find out more information. We have a really strong NSX community, which is accessible via communities.vmware.com that I would absolutely recommend you take a look at. We have a broad set of resources, whether that's white papers, design guides, solution briefs that are available at vmware.com/go/networking. And then we've got a network virtualization blog that I would also highly recommend, which is available at blogs.vmware.com/network virtualization. If you want to take the level of detail to the next level and get some hands-on experience, we have free-to-access labs that are available at labs.hol.vmware.com. And I'll emphasize those are free to access, so I'd highly recommend taking a look at those as well. If you've got any questions, I'm going to stay on the bridge, so feel free to ask any additional questions. I will also take a look at the Q&A and answer any questions in due course. there as well. So I'd just like to reiterate again, thank you very much for your time. I hope this has been useful. Thank you.